Hello guys, my name is Sergei. I'm coming from a bit different world of machine learning data science, and I'm working as a data scientist in a small Finnish company called Dane Studios. It's a consulting company, and we make projects for many other Finnish and German companies. We had some projects on client's infrastructure, on Amazon AWS infrastructure, and 2 projects on Azure. And I was developing product on Azure and enjoyed. In this, it's okay to ask question anytime. In this talk, I will briefly give you information about what type of data science infrastructure Azure can offer you, what capabilities, infrastructure, and the second part of my talk is going to be quite long demo, I guess. Well, Microsoft has been through many changes. They acquired quite many companies, and they worked with many companies. They had many demands. So that's why this machine learning environment really developed and flourished. There are many environments now, basically. And at the beginning, it was like one monolith infrastructure, and now they can offer a lot of microservices, which made life really easy and fast. And in the middle, as always, there is Azure portal, and every piece is connected to Azure portal. In Azure portal, you can, of course, manage almost everything, and then from there you can connect with everything else. So the most integrated piece of that, and the most traditional, I guess, is an HD Insight, the oldest one. And it sits inside Azure infrastructure, and you basically fire up your machine, and it has a Hadoop cluster inside, and on top of that you can have whatever machine learning tools you want. And of course you start that from Azure portal. Then, of course, you have the closest connection to your data, which is quite important. Then they built this Azure Machine Learning Studio, which is similar but quite different and targeted just only for machine learning, which is a really nice tool. It has some connection to Azure portal, and of course you can use the same login. Then quite a recent tool is Jupyter Notebook, which they basically took free distribution and built their own solution. That one, it has a connection to Machine Learning Studio and Azure portal. Then very new solution is integration with Databricks. And those of you who don't know, Databricks is a company, is a main contributor of Spark. They have their own environment, and you can very easily connect from your Azure portal to their environment. Then probably the most distant piece is R server, which can live on its own without even integration to Azure portal. So, but of course, you can start the same R server from within Azure portal. Then, what are the benefits of using Azure? Well, comparing, for example, to AWS, it's more about convenience and what type of infrastructure you have already. And of course, Microsoft really takes care so you can use your login to access anything. It's pretty fast. And they, like around 3 years ago maybe, they acquired this Revolution Analytics company and built a lot of products on top of that. And they decided to go into this free software world as R, Python, and they now have many products. And which really convenient in Azure is that you can develop things on your laptop, and then with the same code, moving to Azure, you can scale it out and enjoy running in cluster. Let's switch to particular technologies. Microsoft R Server. Basically, it's a free software which you can install on your own infrastructure, and in the core there is a traditional R with some Microsoft libraries which offer you to connect to the infrastructure and to use some web tools, like for example, then some applications may connect to your web services, which are made from R server. And the idea here is that many users can connect to just one server and develop models, upload them, and make a web server out of it, and then feed them to users. And now there are two languages already, R and Python. Before it was only R. And with Python you have quite similar functions and quite similar environment. There are some quite important packages which go along with our server. Those are develop R, which is similar to RStudio. Then, of course, there is integration to Visual Studio, and new one, develop R. Then there is package distributor, which includes some drivers to connect to Microsoft SQL Server or Hadoop or anything else. And they developed their own functions to manipulate data and to train your models. So if you see Rx before any function, that means it's this function created by Microsoft, and it runs a distributed job under the hood. But essentially, it's quite similar to traditional R functions. And a very nice tool, Deploy R, which allows you to upload your model to any server and have a nice API to your model. I guess we'll go through demo. And of course, Microsoft allows you to scale out your model, so you can have not just a simple app with one node, but many apps. It's of course obvious. And the very light machine learning environment is a Jupyter notebook. It's very recent, and it's currently under development. And one can see that they build new tools, and not everything is working that good. I even had made a request on the GitHub to renew the driver to access SQL Server. And I'll show you how to work with it. But basically, if you want to make things faster, basically connect to that notebook. You don't even need to pay for now. And then upload your model, for example, to your cluster or to Microsoft cluster. And the latest thing they made, and they are very proud of it, is integration to Databricks. Databricks is a very powerful environment. They have their own storage, and they claim that their storage is optimized for Spark jobs. And it's very convenient to work in a team, because the whole team can work just on one notebook, and then run this notebook as a job. And the main integration is, of course, with Azure portal. So let's switch to demo. Yes. Let me do some logins first. So let's start with the Azure portal. Here inside I created a database with I guess it's default, one of the default ones which they offer. And of course we can run some simple scripts from inside of Azure portal, for example. Yeah, here you may see the result, but you cannot do much with it. Once you have to move somewhere else anyway. And what else you can do here? There is, of course, security table, which is quite important if you want access from some other environment. Especially from your own environment. And you need to put in your IP address there. Probably the most important web page is this Machine Learning Studio. which is quite nice. It allows you to run things even without knowing a single line of code, without knowing R, Python, or anything. It has a drag and drop interface, and let's success one experiment. So they have this nice data flow, and it starts with some data coming in, and you may upload your own data. You may take data from blob storage or from Microsoft SQL. But here is a default example, I guess. Then from here, from left side, you basically drop some stages, like split the data for test and train. Then you have a model here. They offer quite many models: regression, classification, clustering. And then at the very end, you have a box where you can save the result data from, or you can look at your model and save it also to local storage. Into Machine Learning Studio, it has its own storage. But you can access any box here and see what it contains. So, for example, this one, it's a table. You may see distribution already, which is quite nice and makes things faster. Then if you have a model here, and once you access it, you see this pretty nice calls of R functions under the hood, and essentially you may copy paste it into your R and run it as a program programmatically. Then it's run. Then the second example. Which is simpler. And here at the beginning you have, there is a connection to SQL database with some SQL query. I guess it's the same that I run here. And you don't need to establish any additional access or to know API address. Azure portal and Machine Learning Studio, they are connected behind the scene. And for example, after you run the model, you get the result. You save the result into local machine learning storage. Save as dataset, give it a name, you save it. Then, for example, you go to this storage, and you may see it is saved, this one. Then there are many things you can do with this file. For example, you can open it in a notebook, one of 3 languages. For example, I want to run Python scripts on it. And why it's not working? Yeah, like that. And this notebook opens connection to that file, and you don't need to specify any tokens. any IP address. It's just simple as that. You just run it up, and you have it. Then you can run some additional model from within this notebook. Then there is possibility to access this file from my local laptop. For that, I need to get some authentication. Generate that access, yes. This one. I make copy paste. I go to my local RStudio, and after some installation of Azure package, I run the code and I get the data. And I can also run anything, do anything with the data from my local machine. And here I access the data with our notebook, and I'm running our scripts.
Question, do you know if
yes.
Notebooks.azure command or GPU enabled in that kind of file?
Here, no, it's not possible, I guess, because they miss some drivers, and you don't have access. I can show you, by the way, that you may access command line from here. Basically, click on this Jupyter sign. Then from here, you make new terminal. And from this terminal, you may see what they have. They have our library, our libraries, and you may check your rights of this NB user. You may check what drivers they have, but you cannot install anything on your own. I couldn't even install Spark on it. And what you do, you go to their GitHub and you ask them, and in some months maybe they make it. But they miss quite basic stuff. They are far away from running models on GPU. For the GPU, I guess you need to go to Azure portal. Where is it? And create create your own machine from there. Yes. But this notebook is quite simple, fast, and easy to prototype. Easy to look at the data, understand it. So here I run some really simple linear regression. Then I make a function to upload it to Machine Learning Studio and make API out of it. So anyone with the key or without key, depends on how I set it, may send some data and get the result of this linear regression. And this function basically uploads my model, which is this function basically, with this environment settings, WS, which are specified here as workspace. I run it, then I go to Machine Learning Studio, I go to Web Services, and I see it's been uploaded. just now. Then, for example, I access it. I can run tests just from within it. This is my X, and as output, I have what? Why nothing is given? Here, yeah, here is the result of it. It's basically the response. And here you have access key, configuration of your model, you can see variables here, weight, and for one weight there is one answer. So what else can you do? You can access that as an API from your local notebook, from RStudio or from anywhere else, and you get the response as JSON, I believe. So this is API key, which I showed you before. And I have 3 exes, which will be sent to Machine Learning Studio, and I'll get 3 results from that. It's running, and yeah, I guess succeeded. Yeah, here are 3 answers from it. Then there is storage, which I showed you. This one, I don't know. Yep. And yes, the last one, but the coolest one, and I like it the most because it's very modern and allows you to do more things than the rest. First of all, I need to run cluster. How to do it? Start cluster, yes. I guess it will take some minutes. Well, I'll tell you what it allows to do. So it has a connection to Azure storages, or you can run completely separated, not related to Azure scripts, just with your storage. It allows you to run scripts in distributed fashion. Of course, as any Spark program, it has API of R API, Python, Scala, and SQL. And with SQL is quite cool because you can run SQL scripts just like in a normal SQL database. So first we need to start our session and connect to our library. Let's wait. Anyone has questions? Maybe?
If we want to learn more about the machine learning in Azure specifically, do you have any suggestions on where to start?
Yep. Regarding the notebook, they have this storage repository, let's say. It's GitHub separated, but they try to make integration with GitHub, so you can bring some libraries to that. And they have some tutorials. So, for example, This one is website APIs. Let's go to main page. Python for data science. Basics.
You can run Keras or TensorFlow.
You can install your own libraries from here, for example. This is Python. I didn't try to install my own libraries that much on Python, but in R, for example, what you can do, you can run traditional R installation function. I don't remember how it's called. Just Keras. Oh, really? No. Just Keras. Ah, it should be in like that. Yeah, it will install Keras package for you, but it might not work well because Keras on R uses TensorFlow Python anyway, so you might want to try it to run on Python notebook, and it should work. But now Databricks, they have their own deep learning library, which is called, I don't remember, SparkDL, I guess. And in Spark 2.3, the recent one, it should be by default, I guess. So you just need to know functions, which functions to run, and basically go to this portal and run it. I guess it's working now. Let's try to initialize the Spark R package first. Then we access our SQL storage and bring the data inside the environment. Yeah, we have it now. Then we inspect the table, basically, which column it has. Then we print schema, which is quite important for distributed datasets, especially when you have nested structure. But here we have a very simple one. This one shows how many distinct values there is in each column. And to visualize, you may use some R packages like ggplot. It's installed by default, or they allow you to call their own function, display, and then a table which you wanna show. Those are unique number of unique values, I guess. And then you can manage what type of graphs, what columns you want to show, what aggregation level, and so on. And then, for example, if I want to run SQL scripts on my distributed dataset, which are now distributed in this Spark cluster, I make a temp view. So I had distributed dataset df, and now it's going to be called df SQL. And then I can run just traditional SQL scripts on it. Like that. I just tell this notebook that I'm going to be running SQL scripts, and then just make a select from that. And at the same time, I might show, I can see the result. But if you don't like SQL scripts, you can run, SQL scripts can run traditionally inside some functions. And this is it. And I'm kind of sharp on time. If any more questions, last opportunity to get ticket.
One question about if you have a pre-trained machine learning model, for example, using TensorFlow or PyTorch or something like that, how do you, bring that up in the Azure machine learning environment and, for example, publish it as a REST API for the application that wants to use it? So does the Azure machine learning tools provide an easy way to publish and deploy these trained models as services to applications?
Well, the easiest way to make a web service, I showed you that you can run it from Machine Learning Studio. It has this web services.
So you would create a new notebook and import that pre-trained model?
Yes, basically push it here. But of course, if you want to have a scalable application, then you need to have many machines under the hood. Then you would go to Azure portal and create a cluster, for example, or load balancer out of some machines. Then it's going to be not that easy. Here I try to show you the easiest way, just to test, for example. But of course, if you have this model, then you pass it to someone who upload it into right environment. And Databricks, they really promoting using Spark now, because from any language, even from SQL, you can save your model as a jar file, which then can be fed to Java or Scala, which really makes things simpler, and there is no this gap anymore between data scientists and data engineers. And I guess I like the question about GPU. I don't remember who asked that. Okay. Do you already have ticket to Tech Days?
Actually, no. And I would like to go if you have a ticket.
I don't have it. I need to get it myself. Yeah. Thank you guys for questions, for listening. I don't know if it was helpful. Hopefully.